Hello friends, continuing with the topic of electrical capacitance, today we take up third part of it, polarization. Now what is polarization? Let us try to understand it. When a dielectric slab is subjected to uniform electric field, it becomes polarized. This phenomenon is known as polarization. Now how it becomes polarized? Let us try to understand. Let a dielectric slab with thickness T is introduced between the plates of a parallel plate capacitor. Rearrangement of charges takes place in dielectric slab as shown in diagram. Now, negative charges accumulate at the surface near positive plate and positive charges accumulate at the surface near negative plate. Thus, the dielectric slab becomes polarized in the direction of applied electric field, and an electric field ES is produced inside the slab in opposite direction to the applied electric field. Okay. Now, after understanding that how a dielectric slab becomes polarized, we define the polarization. Thus, polarization is the phenomenon by virtue of which atoms or molecules of a dielectric substance becomes polarized when placed in uniform electric field. So this phenomenon is known as polarization. Now mathematically it can be stated as the dipole moments developed per unit volume of a dielectric substance when placed in uniform electric field, and is expressed as capital P is equal to dipole moment vector P divided by V. V is volume of the dielectric slab. Thus P is equal to capital P is equal to dipole moment vector P divided by volume V. Now SI units of polarization: coulomb per meter square. So coulomb meter for dipole moment vector and meter cube for volume. So finally resultant units comes out to be coulomb per meter square. Now fourth, polarization of dielectric slab is equal to induced surface charge density, that is P is equal to sigma I, where sigma I is induced surface charge density and capital P is polarization. Therefore we write P is equal to sigma I. Now let us prove it, how it comes out to be. Let Qi be the charge of each atomic dipole and T be the separation between plus Q and minus Q. Then dipole moment due to each atom, say Pi is equal to Qi into T. If there are n such dipoles produced, then total electric dipole moment produced, say Pt, is equal to n into Pi, or it is equal to n into Qit, or it is equal to Qit, where Qi is equal to nQi and is the total induced charge on the slab. Now P, polarization P is equal to dipole moments, total dipole moments per unit volume. So Pt divided by V, or we can replace Pt by Qit and V by At, area into thickness. So Tt cancels, so we are left with Qi by A, and Qi by A is nothing but sigma I, surface charge density. Thus we can say polarization P is equal to sigma I. That is, polarization is equal to induced surface charge density. Okay. Now, fifth point, let us see electric field inside the slab. Now, electric field inside the slab, say ES is equal to sigma I by epsilon naught, or it is equal to P, because sigma I can be replaced by polarization. Sigma I is induced surface charge density, and induced surface charge density is equal to polarization. Therefore, we can write ES is equal to P by epsilon naught. Sigma I is replaced by capital P, that is polarization. Now, sixth step, electric field in the region occupied by the slab. Say EA, that is equal to E naught minus ES, and therefore EA we can write as E naught minus P by epsilon naught. Okay, because ES is equal to P by epsilon naught. Now, seventh, also polarization P is equal to epsilon 0 chi into EA, where chi is known as susceptibility and describes the electrical behavior of dielectric slab material. Now, eighth step, relationship between dielectric constant and susceptibility chi, that is epsilon R is equal to 1 plus chi. Epsilon R is relative permittivity or dielectric constant. Sometimes we write it as by K. K is equal to 1 plus chi. So here I am writing by epsilon R equal to 1 plus chi. Now let us prove it. Since electric field intensity in the region occupied by the slab material is EA equal to E naught minus ES, and therefore EA is equal to E naught minus P by epsilon 0. But P is equal to epsilon 0 chi into EA. So we replace the value of P by epsilon 0 chi into A. That is, we can write therefore EA is equal to E naught minus epsilon naught chi EA by epsilon naught, or it is equal to E naught minus chi into EA. Epsilon naught cancels. Or we can write E naught. From above equation, we shift minus chi into EA on one side, and then on one side only E naught remains. So therefore E naught is equal to EA plus chi into EA, or we take out EA common into 1 plus chi, or we can write it as E naught by EA equal to 1 plus chi, because epsilon R is equal to E naught by EA. Therefore we replace E naught by EA on left hand side by epsilon R. Therefore we can write it as epsilon R is equal to 1 plus chi. So this expression shows that if we add 1 to susceptibility, we get dielectric constant of the substance. Now atomic polarizability. Electric dipole moment produced is directly proportional to the applied electric field. That is, P is directly proportional to epsilon 0 E0, or P is equal to alpha into epsilon 0 E0, where alpha is constant of proportionality and is known as atomic polarizability. Thus, alpha is equal to P divided by epsilon 0 E0 and is defined as the dipole moments produced per unit electric field per unit absolute permittivity of free space. I repeat, the dipole moments produced per unit electric field per unit absolute permittivity of free space is defined as atomic polarizability. It has dimensions of volume. Therefore, SI unit is meter cube. And now assignment 2.3 continued. Question number 9. What happens when a dielectric slab is introduced between the plates of a parallel plate capacitor? Question number 10. How dielectric constant and susceptibility are related? Derive the expression. Question number 11. Define atomic polarizability and give its SI unit. Okay, thank you so much for this. Next time we'll take up the next part, fourth part of electrical capacitance. Thank you once again. God bless you.